All right, guys, we are going to start our look into trigonometry by actually looking at some more ratios and some right triangles and actually a little bit of the Pythagorean theorem. So I'm going to try to make today quick and easy for us because I know it's a little bit weird you being in the classroom and me being here. So let's just jump right into it. So we're looking at this triangle here below, okay? And we actually saw some of these on our review. I told you to skip up for the midterm exam, but I have this triangle with the altitude drawn down from the right angle. And the question I have for you is, are these three right triangles similar to each other? The one on the left, the one on the right, and the big one. So I encourage you to take a minute and think about that. But it's actually a pretty easy way to prove that they are. So I'm going to do something, and I'm going to say, let's just pick an angle. Let's just say, for example, that this angle here is 60. It's probably not 60, but let's just say it is. If that angle is 60, what must this angle here be in A? If we think of that triangle on the left, the medium triangle on the left, if I have a 90-degree angle, a 60-degree angle, this must also be 30, because I have to sum to 180, right? So that must be 30. So if I look at that triangle on the left, right, maybe I'll even outline it in red, we can say, okay, this is just an example angle. Okay, you could pick anything you want. Let's now look at the triangle on the right. Or actually, let's take a look at the big triangle. Let's take a look at the big triangle here. I want to outline that in green. We already know we have a right angle up top. Okay, we have that right angle up top. If this bottom left angle is 30 degrees, what must angle C be then? Angle C must be 60, because again, if you look at the big triangle, if angle B up here is 90 and angle A is 30, then angle C must be 60, because they also have to sum to 180. If I now look at that small triangle on the right, what color can I use? Maybe blue. If you look at that triangle, I already know that the altitude, the bottom part right here, is 90 degrees. I know the angle C is 60, I just filled that in. Then what must angle B be in that little triangle? That little angle in there must be 30. Okay, and you can see it kind of makes sense because we have a right angle there for the entirety of angle B. If that one half is 60, the other half must be 30. So I have three triangles with a 90-degree angle, a 30-degree angle, and a 60-degree angle. Are these three right triangles similar? Yes, they are. Now you might say, well, Mr. Bodner, what if I chose 40 degrees instead of 60? Would it still work? I encourage you to try it if you don't believe me. Any angle you put in, as long as you follow the rule that all the angles inside each triangle sum to 180, it will make sure that the three triangles are similar. So what's kind of the trick here is that if you draw an altitude from the right angle of a right triangle, if you draw an altitude from the right angle of a right triangle, it will actually form three similar right triangles. So for example, if we know these three are similar, let's say well, then I know I can compare the ratios. I could say maybe that AB over BC, AB over BC equals, what could AB over BC equal? Let's take a look at what AB is. AB, okay, AB is that side there, and BC is that side there. Now, there's a lot of different ways you can compare it, okay? But AB, if we look at the big triangle, is the side opposite 60, and BC is the side opposite 30 in the big triangle. So we have opposite 60 over opposite 30, okay? So if I look at maybe the smaller triangle, what's the side opposite 60? The side opposite 60 in the smaller triangle is BD. Okay, the side opposite 30 is DC. So there is one ratio I could say. I could say AB over BC equals BD over DC. And that's something I certainly can say. Okay. Again, there's other answers to it. As long as you are consistent, right? I always like to write this little ratio out here, saying hypotenuse over opposite 30 or opposite 30 over or opposite whatever angle you have over hypotenuse. Just make sure you're really careful with how they line up. Okay. Now, let's take a look at the problem below, and I'll show you kind of how I think about this. So it says use the diagram below to find the values of h, a, and b. Okay, h, a, and b. Now for me, and this is totally your call, it really helps, allows me to keep things straight if I just put in example angles. I know these actually aren't the angles, but they're example angles to help me keep things straight. So I'm going to say that this angle here is 40 degrees. I'm just saying it is, just to help me keep my sides straight, which means this angle right here must be 50, this must be 40, and then this must be 50. Again, since I have an altitude coming down from the 90-degree angle of a right triangle, I know those three triangles are similar. The angles actually aren't 50 and 40, but if I put them in, it helps allow me to keep corresponding sides in line with those three similar triangles. And I'll show you what I mean by that. So use the diagram here to find the values of h, a, and b. All right, so let's maybe first start with h. So if I'm trying to find h, I basically need to set up some proportion that involves numbers and h. Okay, so if I'm looking at maybe the triangle on the left, okay, the triangle on the left, I have 7 and I have h. 7 is the side opposite 50. H is the side opposite 40. Again, I don't know that those angles are 50 and 40. I'm just using it as an example. But if I stick with that ratio, the side opposite 50 is 7. The side opposite 40 is h. Okay? Are there any other triangles that you see where I have a side opposite 50 and I have a side opposite 40 that only involves 7 and h? Well, if you look at the small triangle on the right, the side opposite 50, okay, the side opposite 50 is h. Okay, I'm just going to put higher there. And the side opposite 40 is 3. So I have a ratio now of 7 over h equals h over 3. So solving that cross multiplying, I get h squared equals 21, or h equals root 21. So let me change colors. So I know h is just equal to root 21. So the trick to this is kind of finding two sides amongst two triangles where you have a number or multiple numbers and a variable. If I had multiple variables here, it would have you would have had to maybe set up some type of system or something. We're certainly not up to that point yet. All right. All right, so next question might be, all right, well, we solved for h. How do you solve for a and b? Well, let's go back to this little small triangle on the right. I now know side h. I know side 3. How would you solve for the hypotenuse? Well, it's as simple as doing the Pythagorean theorem. I could do root 21 squared plus 3 squared equals b squared. I get 21 plus 9 equals b squared, which equals 30. So then b needs to equal root 30. I don't think that can be simplified. So that's just going to be root 30. And now if we look at this big triangle, that's side A, there's a couple different ways you could solve for it, but let's just maybe take a look actually at the triangle on the left. I have side H and I have side 7. I could say that 7 squared plus root 21 squared equals a squared. So you can see Pythag comes in handy quite a bit once we did that first ratio. So we get 49 equals plus 21 equals a squared, or a squared equals root 70. I don't think we can simplify that. Okay? So again, the key to these problems, set up those example angles. You don't have to do it that way, but again, it allows me to keep all the sides straight in proportion with one another. You don't have to choose 50 and 40. If you have other ways of keeping all the sides straight, you can. I just like to use example angles, just remembering that those actually aren't the real angles and you can't use those angles to make some type of calculation based off the values of those angles. You just use them to keep them straight, okay? All right, so if we look at again, if we scroll down, go to the next page, there are 3 problems, 2 through 4, okay, that are similar in nature, where I have a big right triangle with an altitude being drawn down from that right angle, which means we know now that those 3 triangles are similar. So what I would like you to do is to do those 3 problems, okay, do those 3 problems, solve them, the solutions are on Canvas, okay, talk with your classmates if you're in school, if you're at home, okay, do the best you can. If you want to FaceTime with a classmate, you can do that, all right? Work through those 3 problems, and then when you get done, it's either for homework or for class time if you get it done in class. Once you've done those 3, I want you just to do this next page, the Pythagorean theorem and its converse. You don't have to go beyond that, so only through problem 5. Do not go to special right triangles. You don't have to do that. But what I want you to do is I want you to write out the Pythagorean theorem, but I want you to write it out in a sentence, i.e., when can you use the Pythag? Any type of triangle? Does it need to be a certain type of right triangle? So I want you to write out the Pythagorean theorem, and then I also want you to write out the converse. The converse just means the reverse. Okay, I'll give you an example of a converse statement, and then I want you to write the converse of the Pythagorean theorem once you've defined the Pythagorean theorem. So I'll give you a quick example of a converse. If it is cold, I'll wear a jacket. So there's my statement. Okay? Okay. What's the converse of that statement? Well, if we think about this statement right here, if it is cold, I'll wear a jacket. I have 2 parts. Okay? I basically have what is a hypothesis, and then I have a conclusion. Okay, my hypothesis says if this is true, then I'll wear a jacket. Okay, so I have a hypothesis and I have a conclusion. A converse of something is switching the conclusion and the hypothesis. Okay, so the converse of this would be if I wear a jacket, it is cold. You can add outside here if you want. Okay, but notice how I switched the 2. I switched the hypothesis and conclusion. The original statement being, if it is cold, I'll wear a jacket. The converse, again, is the switching of the hypothesis and conclusion. If I wear a jacket, it is cold outside. The statement in converse may not always be true. Okay, I could make a statement that is true, but its converse may not be true. Something like, well, I'm trying to think of one that wouldn't be true. I don't want to waste my time thinking about it. But it doesn't always have to be true. So I want you to start by writing the Pythagorean theorem as an if-then statement. If we know something about this triangle, then what can I conclude? If blank, then blank. And then write me the converse. And then once you do that, okay, I want to see if you can don't worry about this step right here. Don't worry about this unless you think you can figure it out. But I do want you to try number 5. See if you can determine if triangles in A, B, and C are acute, obtuse, or right. And I want to see kind of what your answers are, how you're thinking about it. If you don't get it or you're not 100% sure, that's okay. But try to come up with a little bit of hypothesis on those, okay? So give it your best shot. If you're struggling, talk with a classmate. Hopefully I'll be in tomorrow and I can help answer some questions that you have, okay? Good luck, and hopefully we'll see you tomorrow.